Welcome to YQ Academy Collections Framework Java Interview Questions and Answers. 1. Difference between ArrayList and LinkedList. 1. Underlying data structure. ArrayList internally uses a dynamic array to store elements. It provides random access to elements based on their index, which means accessing elements by index is efficient. On the other hand, LinkedList internally uses a doubly linked list to store elements. It does not provide random access and requires traversing the list to access elements. Insertion and deletion operations in a linked list are more efficient compared to an array list. 2. Insertion and deletion. In ArrayList, inserting or deleting an element in the middle of the list requires shifting elements, which can be an expensive operation for large lists. On the other hand, linked list performs better in such scenarios as it only requires updating the references of neighboring elements. 3. Memory overhead. ArrayList has a higher memory overhead compared to linked list. ArrayList needs to allocate contiguous memory for its underlying array, and it may need to resize the array when it reaches its capacity. Linked list, on the other hand, needs to allocate memory for each element and also stores references to the next and previous elements. 4. Iteration. Iterating over elements in ArrayList using indexes is faster compared to linked list. Linked list, being a doubly linked list, requires traversal of each element to access them. 5. Usage. ArrayList is generally used when random access to elements or frequent element retrieval by index is required. It performs well for scenarios where elements are accessed sequentially or through index-based operations. Linked list is suitable when frequent insertion or deletion of elements is required, especially in the middle of the list. 2. Difference between comparator and comparable in Java. Comparator and comparable are both interfaces in Java that are used for sorting and comparing objects. 1. Purpose. The main difference between comparator and comparable is their purpose. The comparable interface is implemented by the objects themselves, allowing them to define their natural ordering. On the other hand, the comparator interface is a separate class that defines the comparison logic for objects that may not have a natural ordering or when a different sorting order is needed. 2. Method. The comparable interface defines a single method called Comparator, which is implemented by the objects themselves. This method compares the object with another object and returns a negative integer, 0, or a positive integer to indicate whether the current object is less than, equal to, or greater than the other object. The comparator interface, on the other hand, defines a method called compare. This method takes two objects as arguments and returns a negative integer, 0, or a positive integer to indicate the order between the two objects. 3. Implementation. To use the comparable interface, the objects class needs to implement the interface and provide the comparator method. This allows the objects to be sorted based on their natural ordering. To use the comparator interface, a separate class needs to be created that implements the interface and provides the compare method. This allows for custom sorting logic to be defined for objects that do not implement comparable or when a different sorting order is required. 4. Flexibility. The comparator interface provides more flexibility compared to the comparable interface. With comparator, you can define multiple comparison rules and easily switch between them by using different comparator implementations. This allows you to sort objects in different ways without modifying their implementation. With comparable, the comparison logic is fixed within the objects class, and you cannot easily switch between different comparison rules without modifying the class itself. 3. What is concurrent HashMap and its features? Concurrent HashMap is a class in Java's concurrent utilities that provides a concurrent and thread-safe implementation of the map interface. It is designed to support high concurrency and is suitable for multi-threaded applications where multiple threads are accessing and modifying a shared map concurrently. Features of concurrent HashMap. 1. Thread safety. Concurrent HashMap is designed to be thread safe. It allows concurrent access by multiple threads without the need for external synchronization. It achieves this by internally partitioning the map into segments and providing fine-grained locking on each segment instead of locking the entire map. 2. Performance. Concurrent HashMap offers high performance in multi-threaded scenarios. By using internal locks on each segment, it allows multiple threads to access different segments simultaneously, reducing contention and improving scalability. 3. Scalability. Concurrent HashMap is designed to handle a large number of concurrent operations efficiently. It dynamically scales the number of segments based on the number of threads accessing the map, allowing for better distribution of load and minimizing contention. 4. Iteration. Concurrent HashMap provides a consistent and reliable iteration over its key-value pairs. The iterator returned by concurrent HashMap's keyset, entry set, and values methods will reflect the state of the map at the time of creation and will not throw concurrent modification exception, even if the map is modified during iteration. 5. Concurrent updates. Concurrent HashMap provides atomic operations for concurrent updates. It offers methods such as putIf absent, remove, and replace that can be safely used in multi-threaded environments without external synchronization. 6. Support for null values. Concurrent HashMap allows null values to be stored and retrieved, similar to other map implementations. 7. Memory consistency properties. Concurrent HashMap provides the same memory consistency guarantees as other concurrent classes in Java's concurrent utilities. It ensures that changes made by one thread are visible to other threads accessing the map. 4. Difference between concurrent HashMap and HashTable and collections. Synchronized HashMap. 1. Concurrency level. Concurrent HashMap allows concurrent access to different segments of the map, enabling higher concurrency and scalability. It internally divides the map into segments and provides locks at the segment level. On the other hand, HashTable and collections. Synchronized map use a single lock for the entire map, which can lead to contention and reduced concurrency in highly concurrent scenarios. 2. Performance. Concurrent HashMap generally offers better performance than HashTable and collections. Synchronized map. It achieves higher concurrency by allowing concurrent read and write operations on different segments. This can result in improved throughput and reduced contention compared to the synchronized approaches used by HashTable and collections. Synchronized map. 3. Null values. Concurrent HashMap allows null values to be stored and retrieved, similar to other map implementations. HashTable, on the other hand, does not allow null keys or values and throws a null pointer exception if null is attempted to be inserted. Collections. Synchronized map behaves similarly to the underlying map implementation. 4. Iteration. Concurrent HashMap supports concurrent iteration without the need for external synchronization. It provides a consistent and reliable iteration over its key-value pairs. HashTable and collections. Synchronized map also support iteration, but external synchronization is required to ensure thread safety during iteration. 5. Legacy. HashTable is a legacy class that has been available since the early versions of Java and is thread-safe by default. Collections. Synchronized map is a utility method that wraps any map implementation and provides a synchronized view of the map. Concurrent HashMap was introduced in Java 5 specifically to provide a highly concurrent and scalable map implementation. This is the end of our Java interview questions. We hope you enjoyed learning with YQ Academy. Until next time, goodbye.